All right, now I'm going to request my friend Arpit to come on stage and curate the final showcase session and also close the session for us, please. Thanks, Arpit.
Hey guys, I'm back. I'm not sure how many of you were there. Hey, don't leave. Of course you can. So this time, there are only going to be two presentations. Exciting. I mean, I'm personally very excited about this company called Ethereal Machines, which will be at the last. And of course, fluid robotics, which is also very exciting and solving a uniquely Indian problem. He will show you some pictures and you'll know what I mean. So give me 1 minute. Let me set it up. You can feel free. You can use this one.
Hi, my name is Asim. I'm one of the founders of Fluid Robotics. We're a 2-year-old startup based out of Pune, and we're building solutions for smart infrastructure management. What I mean by that, we're looking especially at the pipeline infrastructure that's in urban cities. So most of us are aware of the challenges that cities face in terms of water loss. There's inadequate water and water pollution. You see, most of our urban water bodies are quite polluted. If you look at the water distribution system right from source to homes and industries, because of the infrastructure being really old, you have about 50 to 60% of water that gets lost through leakages. If you look at your wastewater infrastructure, so once the water is consumed, this water goes into a collection system, so sewage pipelines, and it's then supposed to get to a treatment plant and get filtered. So about only 15 to 20% of this wastewater actually gets treated. The rest of it enters water bodies untreated. So, all of these problems stem from the fact that the location and health of this underground infrastructure is largely unknown. So you have a lot of issues such as monsoon flooding as well that happen because of clogged pipelines. So the environment that we are trying to work in is quite dangerous and unknown. Nobody has looked into these pipelines in some cases for over 100 years. So what we're doing to solve this problem, we've built a system, basically it's a multi-sensor robotic system that can either drive in a pipe, float on water, or even go underwater. And what we're doing is we're doing an angiography of these pipelines. So we have an end-to-end diagnostics framework right from data collection in these pipelines to analytics and visualization. And the issue today is the alternative to this solution is usually human entry. And all of us have read about that in the newspapers. So this is our rover that travels through small, by small I mean 6-inch minimum diameter pipelines upwards. And as the robot travels, we're creating a map of this pipe, and we're also trying to understand the health of this pipe based on structural issues and any other observations that we have. So if you look on the right, that's a network laid out. It's color coded. We look at the severity, break that up into 5 levels. 5 are all color coded in red. You see an image of what a 5 level defect looks like. Usually requires entire replacement of that section of the pipe. And the conditions in these pipes are also quite dangerous. So you have a lot of hydrogen sulfide buildup, a lot of methane gas buildup. So we really need to have this hardware work in that kind of an environment. So a lot of large diameter pipelines usually run half full or sometimes even completely full depending on the capacity of these lines. So you can see, we deploy sensors below the water line as well to look at the condition of the pipe. So using ultrasonics, and we'll build out the mechanical platform to be able to carry these sensors in this type of an environment. So you have a floating system right here that's carrying optics on the top, and we have ultrasonic under the flow level. So what we've done, with all of this data collection, it's a lot of data. You have videos, high-def videos, you have sensor data coming in. We've built our own neural network framework to analyze all of this data that's coming in for multiple reasons. Saving time is one. training people from different cities, there are a lot of language barriers, so the more automation there is, at least for this part of the work, it's quite helpful. And it allows us to standardize the process of inspection, which usually is very subjective. If somebody calls a crack a fracture, you look at the severity rating of that pipe changing. So we want to be able to standardize that process. And building a system like this allows for scalability. So I'll walk through a few slides on how we've used this technology other than just mapping pipelines and identifying the condition. So what you see here is a map of Nidhi River, where we've, on the right, that's a 3D model that we created to better understand the topography of that area. But we essentially identified all the stormwater drain outfalls, so where the untreated wastewater is getting into the water body. And we have locations that get mapped out with the robot, and we also deploy flow sensors. So MLD stands for million liters a day. So we are measuring the amount of volume of wastewater that's actually getting into the water body. So once we do that, once we've identified all the outfall locations, we map out the entire sewage network around it. So all the green lines are sewage pipelines that are around Powai Lake. And we look at not just the connectivity, so connectivity to treatment plants, we also look at the capacity of these pipelines, and we look at the health as well as the last mile interception. Can the wastewater that's coming in through the stormwater drain, can that be diverted successfully to the sewage pipeline? So what we provide is a solution to do interception and diversion. So our end deliverable is a map designs of these mechanisms and pipelines that connect stormwater drain outfalls to sewage pipelines, essentially taking that wastewater which was previously getting into lakes and rivers to pumping stations and treatment plants. And in Mumbai city alone, we've created plans for diverting a volume of 350 million liters a day, which is currently under implementation, both for Powai Lake and Nidhi River. And we're doing, we're trying to replicate this model for lakes and rivers across the country. So we're talking to multiple states now on how we can use a technology like this to clean up our water bodies, other than just, creating a database of pipelines. Thank you.
So just to let you guys know, he missed out a very important thing, that your Belandu leak is becoming better thanks to fluid robotics. That deserves another round of applause. Thank you. Yeah, next is, of course, ethereal machines. And Naveen is here. Naveen is the brain behind the entire product. Please welcome Naveen. Naveen, this round to you.
Hello, everyone. Thank you for having me here. So I'm Naveen Jain. I'm the CTO and co-founder of Ethereal Machines. And what we do is we are into manufacturing of CNC machines and 3D printers, specifically 5-axis CNCs and FDM 3D printers. So this is basically just to give you an idea of what we are. We have been into this field for about 4 years, 3.5, 4 years. So now let's talk about the manufacturing process. When you look at manufacturing of any hardware, what are the two? So there are basically two types of process. It's either additive manufacturing or subtractive manufacturing. Additive manufacturing, what we all know today as 3D printing. And subtractive manufacturing is CNC machines or CNC milling. Now, there are already machines that are there today that have been there for quite some time, but there are a lot of problems that these machines have. If you see on the slide now, for FDM 3D printers, currently, I would say 99% of the FDM 3D printers are 3-axis machines, which has a lot of limitations. The output that comes out of these machines are fragile. Though we say that FDM 3D printers, the parts produced from FDM 3D printers are one of the strongest, but when you look at the actual industrial application, it does not stand anywhere. It's a very time-consuming process, and the waste material, because of support structures, is a lot. If you have seen any FDM machine printing, you would see there is a lot of support structures which is generated, and you have to essentially break it out, and that is all gone into waste. When it comes to CNC machines, they're massive. They're enormous, they're very costly, and because CNC machine, you essentially take a block of any material and then you cut or chip out parts from it to get your final piece. Now, because of that, the strength to weight ratio is very poor because it's a solid piece. Now, if you analyze it, you can definitely cut down on the weight, or you can definitely play around with the internal structure if you had some other method of doing it, say additive manufacturing. So now to take care of these problems, what we came up with, we call it the ethereal halo. Now, ethereal halo is a combination of 5-axis subtractive manufacturing and additive manufacturing. Now, even additive manufacturing is in 5-axis. So that, I'll just run you through a video first. So I'll explain you what 5-axis is. If you see on the right, the regular 3-axis is happening. Now that is what 5-axis is. So you have your tilt and you have your rotation. The C is rotating and A is tilting. Now what that does is it gives you access to the side faces or multiple faces, which is not possible. Now this video shows in your conventional 3D printers, how do you print a structure like this? You have to build in supports, right? On my machine, or on the ethereal halo, this is how we do it. So you get a much better surface finish. There is no problems of support structure. There is no wastage. The time consumption, the material, the cost, it's cut down by at least 1/3 or half. So these are the advantages that you have. And then obviously you combine both the processes. So it opens up a lot of room for you to play around with a lot of material, with the dynamics of the material, the structure of the material. Now, if you have seen an industrial machine, this is how big it is. 2 meters by 3 meters by, say, 1.5 meters. That is massive, and it weighs a lot. This is what our machine looks like if you compare it to the human being. This is the size comparison. So it's small. It can fit onto your desk. And a machine that small, which is capable of 5-axis milling, 5-axis printing, there's nothing like it. So, okay. This video basically shows you what, how a 3D printing happens. This is a regular 3-axis 3D printing process, and now it's the 5-axis part. So you see the tilt happening, and then the rotation happening. Now imagine if you had to print something like this. How would you print it on your conventional machine? You would need to add a lot of support structure below the flaps or the wings, right? Now this machine takes care of all of that. This is the same part which was shown on the regular 3D printers with the support structure. And here you can see it's all done without it. This shows you a video of the milling process. So since the machine is capable of both milling and printing, and you can combine both the processes, as you can see on the video, we play around with materials. So here we're using multiple materials. You can see 2 different colors here. So there are 2 different materials which are being used. There is a non-planar surface on which it's printed. So that opens up a lot of, again, a lot of room to explore new things. When you're trying to make something, say you're trying to make a housing for electronics board, or I would say a wearable tech. Now to make a thing like that, you need a lot of support, or you need, if you go today's method, you need to make a mold and then get the plastic injection molded and then take it out. But with this, you can just print it and then mill out, get the same surface finish that you get on your injection mold, and you're good to go. So to try out things, or to, I would say, prototype, a machine like this helps a lot. So now, what are the problems that has been taken care of? One, the industrial machines have been brought down to desktop size. They have been made very affordable. the term hybrid manufacturing has been introduced, so which basically combines both the process, your additive manufacturing and subtractive manufacturing. And the term 5-axis printing has been introduced, so that enables you to have parts which are much more stronger, removes the entire support structure principle, and basically gives you options to print things which were not possible till date on your regular FDM printers. So the products we have right now is one, the ethereal halo, which you just saw, which I explained about, the hybrid manufacturing machine. We have the pentagram, which is a pure subtractive machine at par with the industrial CNCs in 5-axis, capable of milling all the hard metals. You throw in titanium, you throw in steel, you throw in whatever you want, and it will be capable of machining it. And then we have the ray, which is like your conventional 3D printers, but it's a dual extruder smart machine connected to the cloud. You can again print multiple materials because of the 2 nozzles that you have. You can have multiple colors. So this is basically what we do. So like I said, so basically the segments that these machines can cover, the segments that these machines can cover are, you name it, basically any industry that is related to hardware, a machine like this has to be there. The future, we have generative design. So like I said, if you can play around with the internal structure of the material, you can basically take care of the strength to weight ratio, get better parts. Non-planar electronics. Till date, curved circuits are more or less like a myth. It's there, but it's still not there in the mainstream. So you can make circuit boards which are not flat, which are in any shape you want. Multi-material structures, you can mill something out and then print on top of it and then mill it again. In-part assemblies, so you have parts which have assemblies inside it. You can just make that part, put in the assembly, and then continue with the process in the same machine without having to change the workpiece or making any alterations, or basically getting into the process. That's all. Thank you. If you guys have any questions, I'll be more than happy to answer on the hybrid manufacturing machines.
Time out, we will answer it later.
Okay, that's okay. Thank you.
Thank you, everyone.
But what is the price point?
Thank you, everyone.
It's an end product.
Hey, answer. Yeah, that's it, guys. Thank you. Thanks a lot, guys. It was great to have you, all of you, to be part of this Devices IoT track. We call end of the Devices IoT track with this showcase. Of course, thank you, Arjun. Great. And we have something tomorrow as well here. Yeah, do you know what it is? We have another track here. Okay, sure. Thank you. Great. See you.